Imagine you are drifting through space, not moving fast, not rushing, just slowly floating through the dark, endless quiet. There is no wind, no sound, just silence and the distant glimmer of stars far beyond reach. And then something passes by, not with noise or vibration, but with presence. A beam of light, a soft shimmer of energy, a messenger crossing the cosmos faster than anything else in the universe. This light, moving at nearly 300,000 kilometers every second, holds more than brightness. It carries time. It carries distance. It carries memory. It moves through everything we know and everything we do not. And no matter what we do, we cannot move faster than it. Why does light move at the speed it does? Why is there a limit at all? What makes this speed so special that the universe treats it like a boundary? Tonight, we float gently through these questions, not to solve them all, but to explore them slowly, with curiosity and calm. The speed of light is not just a number. It is a law written deep into the fabric of space and time. It appears again and again in the equations that describe the universe. It shapes what we see, how we age, and even how we understand the meaning of now. But to begin, we must return to light itself. What is it really? A wave? A particle? A field? The truth is stranger than any single answer. Light is all of these and none of them. It is both gentle and powerful. It is both everywhere and nowhere at once. As we drift deeper into thought, imagine holding a flashlight in your hand. You press the button, and a beam escapes into the air. It seems simple. Light travels out and illuminates whatever lies ahead. But now, imagine you are floating through space, far from any star or planet. You turn on the flashlight again. Where does the light go? It keeps moving, forever, in every direction, at the same speed. Whether you are still or moving, whether you are watching or not, the light moves just the same. It doesn't need a medium. It doesn't need a push. It simply moves, always at the same speed. That speed is about 186,000 miles per second. It's not just fast. It is the fastest. Nothing can go faster. Not a spaceship. Not a signal. Not even time itself. And here begins the mystery. This speed isn't just fast. It's fundamental. A cosmic rule built into the universe like the texture of a fabric. And the deeper you look, the more it shapes everything. Time bends around it. Space curves beneath it. And we, tiny observers standing in its presence, are left in awe. Let us now follow that light. Not just as a beam of brightness, but as a message moving across the galaxy. Because every light you see in the night sky is not just illumination. It is a story from the past. A story told at the one true speed the universe allows. Close your eyes now, and let yourself float gently in this space between speed and silence. Let the pulse of light guide you deeper into the questions that shape our reality. And as we continue, we'll begin to explore not just what light is, but why its speed defines the edge of what's possible. Underscore. Part 2. Light's strange nature. To understand why the speed of light is so important, we first have to understand what light truly is. And this question, simple as it sounds, has no single answer. For a long time, people thought light was a stream of tiny particles, like miniature stones flying from the sun and bouncing into our eyes. Then others said no, light is a wave, like ripples on a pond. Something smooth, something that needs a medium to travel through. But light, it turns out, is both. It behaves like a wave and like a particle. Sometimes it spreads out, bends, and interferes with itself like a wave. Other times, it arrives in tiny packets of energy, like drops of rain. These packets are called photons. They have no mass, no rest. They only exist when moving. And they always move at the same speed, no matter how fast the source is moving, no matter who is watching. Imagine throwing a ball from a train. If the train is moving, the ball moves faster because it adds the train's speed to its own. But light doesn't do that. If you shine a flashlight from a moving spaceship, the light still travels at the same speed it always does. It doesn't care how fast you are moving. It always moves at the same speed. That is what makes it so strange. This puzzled scientists for years. And it was Albert Einstein who turned this mystery into a key to the universe. He said that the speed of light is not just fast. It is constant. And to make that work, the universe itself must adjust. Time must stretch. Space must shrink. Mass must increase. All to keep that one speed the same. This idea became the theory of relativity, a way to understand how the universe bends itself around the speed of light. It's not the light that changes. It's everything else. And this means that no matter how fast you move, you can never catch up to a beam of light. You can never overtake it. You can only watch it move ahead, always at the same speed, always slightly out of reach. But why does this matter? Because it defines how far we can see, how far we can travel, how long we must wait. Every distant galaxy you see in the sky is light that left millions or even billions of years ago. You are not just looking across space. You are looking back in time. That light has been traveling at its one true speed since before Earth existed. And this light doesn't just show us the past. It connects us to it. It defines the shape of what we can know. The farther something is, the older its light. The deeper the sky, the deeper the history. And so, light becomes not just a wave or a particle. It becomes a boundary, a limit, a whisper of the universe saying this far and no farther. Let yourself rest in that thought, that you are surrounded by light moving across unimaginable distances, that you are sitting still while messages from across the cosmos flow gently past you. In the next part, we'll explore how the speed of light controls time itself, and how moving fast begins to change the very rhythm of your life. But for now, breathe slowly. Feel the calm of this constant speed, and let yourself drift through space on a wave of gentle light. Part 3. Time slows down. Imagine now that you are in a spacecraft. It is quiet. The controls are smooth. There is no sense of movement, yet you are accelerating. Faster, and faster still. You begin to approach a strange point in reality. Not a wall or a border, but something woven into the very nature of time. As your speed increases, something curious happens. You do not feel it. You do not see it. But if someone were watching you from far away, they would notice that your clock has begun to tick more slowly than theirs. Your heartbeat, your thoughts, even the way your voice would sound to them would all seem to slow down. This is not an illusion. It is real. This is what happens when you move closer to the speed of light. Time itself slows down for you. And the faster you go, the slower your time becomes compared to someone at rest. This phenomenon is called time dilation. It means that for you, time feels normal. You could drink tea, read a book, and watch the stars through the window. But for someone waiting for you on Earth, minutes become hours. Days become years. You are moving through a different rhythm of time. Now imagine pushing closer, approaching the speed of light itself. At that point, your time would almost stop. To you, everything feels still and calm. But for those watching, you appear to be frozen. You are alive, but in a kind of slow motion that stretches toward infinity. And here is the limit. No matter how hard you try, no matter how powerful your engines are, you can never reach the speed of light. Because to do so would mean stopping time completely. It would mean needing infinite energy. It would mean breaking the rules written into the very heart of the universe. Only light itself can move at light speed. Because light has no mass. It does not age. A photon, from its own perspective, experiences no time at all. From the moment it is born to the moment it strikes your eye, no seconds pass. It simply is. And so, the speed of light becomes more than just a measure of distance. It becomes the speed of time, the upper limit of how quickly anything can happen, the fastest that cause can reach effect. This is why we cannot send signals faster than light. Why no message can arrive before it is sent. Why the universe has a built-in order that cannot be broken. And yet, this rule is not cruel. It is elegant. It means that the past remains the past, that the future is still forming, that each moment arrives in its time, in its place. As you float here, gently cradled by space, let that truth comfort you. Time is not slipping away. It is unfolding around you, carefully, at the pace the universe allows. Soon, we will see how this speed affects not just motion, but space itself. How the very structure of the cosmos bends around light. But for now, let your thoughts slow with time. Let your breath match the gentle rhythm of the stars. And feel the steady tick of your own clock, quietly linked to the speed of light. Underscore. Part 4. Shrinking space. Now let us turn to space. Not the empty blackness between planets, but the very idea of distance, of how far things are, of how long it takes to cross from one point to another. In our everyday world, space feels fixed. A meter is a meter. A mile is a mile. But when you begin to move very fast, close to the speed of light, space no longer behaves the way you expect. Imagine again that you are on a fast-moving spaceship. Not just fast like a jet, but unimaginably fast, brushing up against the edge of light speed. Ahead of you lies a distant star, perhaps 10 light years away. At normal speed, it would take 10 years just for your light to get there. But now, because of your speed, something astonishing happens. The distance itself begins to shrink. To someone watching you from Earth, you are traveling a great distance, and it takes years. But to you, inside your ship, the star is closer than it should be. Much closer. The space between collapses. The journey becomes shorter. This effect is not imaginary. It is a real consequence of moving near the speed of light. As time slows for you, space contracts in your direction of motion. Distances compress. You are not just traveling faster. The world is reshaping itself around your motion. This is the universe's way of keeping the speed of light the same for everyone. If you move faster, your time slows. And if your time slows, the space must also shrink to keep your experience consistent with the universal rule. You begin to realize that space and time are not separate things. They are part of one fabric, one field, one quiet canvas stretched across everything. And the speed of light is not just the fastest speed. It is the stitch that binds space and time together. When Einstein revealed this, it changed our understanding forever. The universe was not just a stage where things happen. It was dynamic, flexible, alive. Space could bend, time could stretch, and the speed of light sat at the center of it all, not as a suggestion, but as a sacred constant. And so, light becomes the ruler we measure the cosmos by, not just in kilometers or miles, but in time and presence. A light year is not a guess. It is a real, measured unit. The distance light travels in a year, about 6 trillion miles. And every time we look at the sky, we are using this measure. Every star, every galaxy, every nebula tells us how long its light has been traveling. And that time tells us how far it is. Now you begin to see how deeply this speed defines your universe. It limits how far we can see. It defines the shape of what is possible. It holds the laws of motion, energy, and gravity together. And yet, it feels so simple. A flash, a shimmer, a quiet beam moving through space, whispering the shape of the cosmos into the silence. In the next part, we will step back and ask a deeper question. Why is the speed of light the speed it is? Why not faster? Why not slower? What makes this number so perfect, so unchanging? For now, float in this moment. Let the vastness of space wrap gently around you. Let the quiet beauty of shrinking distance fill your thoughts. You are moving with light now, and the universe is unfolding in its perfect time. Part 5. Why this speed? There is a question that lingers softly, floating at the edge of all this wonder. Why this speed? Why does light travel at exactly this rate, and not a bit more or a bit less? Why is the limit set where it is, and not somewhere else? It is tempting to think there might be a deeper reason, something buried in the mathematics of the universe, a perfect explanation carved into the structure of space itself. But the truth may be simpler and stranger than we expect. The speed of light is what it is because of how the universe is made. Not chosen, not decided, just woven into the fabric. In physics, the speed of light is not just the speed of light. It is the maximum speed at which all information, all energy, all influence can travel. It is the cosmic speed limit for cause and effect. It is the universal translation of distance into time. It emerges naturally from the structure of Maxwell's equations, the laws that describe how electric and magnetic fields behave. These equations, beautiful and precise, say that light travels at a speed determined by the properties of empty space itself. Not by the light, but by the space it moves through. Space is not nothing. Even in the deepest vacuum, there is structure. There is resistance. There is elasticity. These hidden properties, invisible to the eye, set the rules for how light moves. Like tension in a string controls the speed of a wave, the constants of space control the pulse of light. That it is a consequence of the vacuum. of how it responds to the dance of electric and magnetic fields. If these values were different, the speed would be different too. But they are not. And so the speed is what it is. Not chosen by any force. Not adjustable. Just true. You may wonder if this number has meaning beyond physics. Is it a message? A clue? Some have imagined the speed of light as the signature of the universe. A kind of fingerprint that tells us we live in this reality and not another. But maybe it is simpler than that. Maybe it is not a message, but a balance. A point where energy and time and space find agreement. A rhythm that works, that holds things together, that allows stars to shine and atoms to stay whole. This speed is part of a system that supports life, thought, and beauty. If it were too fast, energy might spread too thin. If it were slower, reactions might stall. The stars might not form. The chemistry of life might not work. In this way, the speed of light may not just be a constant. It may be a quiet permission, a way for the universe to say this is the speed at which everything can make sense. As you drift now in thought, let that number echo softly in your mind. Almost 300,000 kilometers per second, or just one constant that holds the cosmos together. Let it comfort you. Let it ground you. Let it be your pulse through the silence. Soon, we will follow this speed beyond space, into time itself, into the far reaches of the universe, and into the beginnings of everything. But now, let the question rest. Not because it has been answered, but because you are calm within the mystery. Part 6. Looking back in time. Imagine standing outside on a clear night. The air is still. The stars shine gently overhead. Each point of light looks immediate, as if it exists right now. But it does not. What you see is not the present. It is the past. Every star, every galaxy, every shimmer in the sky is light that has traveled across the vastness of space to reach you. And because it moves at a fixed speed, that light tells you not just where something is, but when it was. You are not seeing the star as it is, but as it was. Some a few years ago. Some thousands. Some even billions. The farther you look, the deeper into history you see. A galaxy 1 million light-years away shows you what it looked like 1 million years ago. Its current state is hidden, still unfolding, still sending its new light toward you. That light will arrive in time, years from now, maybe long after you are gone. And so, the night sky becomes a kind of time machine. Not in fiction, not in fantasy, but in real, measurable fact. The speed of light means the universe is always delayed, always echoing its past toward us. We never see the now. We always see the then. But this delay is not a flaw. It is a gift. It lets us see what was. It lets us watch the birth of stars, the collision of galaxies, the expansion of space itself. Telescopes, pointed into the deep sky, are not just tools of sight. They are instruments of memory. They gather the light from long ago and bring it to us now. In that light are secrets of how the universe began, how it has changed, how it might end. And this is all possible because of the fixed, faithful speed of light. It is the rhythm by which the cosmos reveals its story. Even the light from our own sun takes time. Just over 8 minutes. When you see it rise over the horizon, that light began its journey more than 8 minutes ago. If the sun were to vanish in this moment, you would not know right away. For 8 more minutes, the light would continue to arrive. Time and light are locked together. Every step forward is also a step into the past. As you breathe slowly now, think of yourself not just as a person in a place, but as a receiver of time. You are surrounded by light. Ancient, recent, ongoing. Each photon a traveler from a different point in history. You are the surface it finally touches. You are the end of its long, silent journey. In the next part, we will ask what this means for the shape of the universe. How does this speed create horizons, edges, places we can never see? But for now, let yourself float in this gentle thought. That light surrounds you. That time is all around. That you are always watching a beautiful delay. You are living in the shimmer between now and then. Part 7. The edge of the observable. The universe is vast beyond imagining. It stretches in every direction with no center and no known end. And yet, there is a limit to how far we can see. Not because there is a wall, not because there is a fog, but because of light. Because light travels at a fixed speed, there is only so much of the universe that has had time to send its light to us. This creates a horizon, a boundary between what we can observe and what lies beyond our reach. We call it the observable universe. This horizon is not physical. It is temporal. It is determined by time and speed. The universe is about 13.8 billion years old. So you might think that we can see objects 13.8 billion light years away. But it is even farther than that, because space itself has expanded during the time the light was traveling. So the true edge we can see is now more than 46 billion light years away in every direction. Beyond that, there may be more galaxies, more stars, more stories. But we will never see them. Their light has not yet arrived, and may never arrive, because the space between us is stretching too fast, stretching faster than light can cross. This creates a kind of shell around us, not because we are special, but because light only travels so far in so much time. And we are at the center of what we can observe, just as any observer, anywhere in the universe, would be. This limit shapes what we can know. It defines the edge of our maps, the bounds of our data, the farthest messages we can ever receive. Not because the rest of the universe is hiding, but because the speed of light defines what we are able to witness. It is like standing in a quiet forest at night with a lantern. The circle of light around you shows the world you know. Beyond it lies the world still waiting. Not gone, not unreachable forever, but silent for now. And this is true for every creature, every civilization, every watcher in the sky. Their own circles of light are different. Their own observable universes are centered around them. Each one is a bubble of visibility moving forward in time. The cosmos is filled with secrets that may never reach us. Not because they are too strange, but because they are too far. And the law of light's speed gently holds them just beyond our grasp. But that makes what we can see all the more precious. Each image from a distant galaxy is a rare gift, a message that took billions of years to reach our eyes. A journey across time and space, honored by the patience of light. As you rest now, picture yourself at the center of this sphere of visibility, surrounded not by emptiness, but by quiet effort. By beams of light traveling vast distances just to say I am here. And know that you are part of this gentle geometry, a point within a glowing sphere, expanding slowly, patiently, beautifully. Part 8. Cosmic Speed and Stretching Space. Now imagine this. You are floating again, not just through space, but through space that is itself expanding. The galaxies are not flying away through a fixed void. The void itself is stretching, like fabric being pulled from all sides. This is the nature of cosmic expansion. And here is where the rules of light take on a strange twist. When a galaxy is far enough away, the space between us and that galaxy stretches faster than the speed of light. This does not violate the cosmic speed limit, because nothing is moving through space faster than light. It is the space itself that is growing, and that growth is not limited by the same rules. So there are places in the universe that are moving away from us faster than light can reach. Not because they are breaking a law, but because they are following the deeper shape of space. This means that light from some parts of the universe will never reach us. Not even if we wait forever. The expansion is simply too fast. And so those places become forever invisible. Forever beyond contact. Forever separate from our story. This is not sad. It is serene. A gentle truth about distance and difference. The universe is vast and full, and we are connected to only a part of it. A precious part. A visible part. A part that unfolds with light and time. Even the galaxies we do see are affected by this stretching. Their light arrives stretched too, shifted toward the red, elongated. We call this redshift. It is not just a visual effect. It is a record of expansion, a soft signature in the starlight that tells us how space has changed. When we look at these redshifted galaxies, we are not seeing them as they are. We are seeing them as they were. And the light that left them left a much smaller universe. One that has grown and cooled and calmed as it spread outward. This redshift is like a memory, a whisper from the early cosmos, telling us not just what things were, but how they moved, how they changed, how the universe itself is not static, but alive with motion. And all of this is possible because of light's steady speed. It gives us a ruler to measure with, a clock to follow, a limit that does not restrict, but reveals. Without it, the stretching of space would be invisible, undetectable, unknowable. But with it, we can trace the shape of the universe. We can see its growth, its age, its story. And now, as you breathe gently, let that thought drift with you. That even in the stillness, the space around you is stretching. That the stars are moving away. that you are part of something grand and expanding. You are a witness to the quiet unfolding of a growing universe, and light is your guide through the darkness. Part 9. Light's role in gravity. Imagine now a beam of light passing close to a massive object, like a star or a black hole. Instead of continuing in a straight line, the beam bends ever so slightly, curving as it moves. It is not being blocked. It is not being absorbed. It is being pulled. Gravity, it turns out, affects light. This discovery changed how we understand both light and gravity. We once believed gravity pulled only on objects with mass. But light has no mass, and still, it bends. Why? Because gravity does not just pull. It reshapes the space around it. A massive object curves the space in which it sits. And light, following the straightest possible path through that curved space, ends up traveling along a bend. This means that light does not move through space as a guest. It moves as part of it. The path it follows is written by the shape of space itself. And that shape is written by gravity. This interaction between light and gravity was predicted by Einstein, and it was proven when scientists observed starlight bending around the sun during a solar eclipse. The stars appeared in slightly different positions because the light from them had been curved on its way to Earth. From that moment forward, we began to see gravity not as a force, but as a warping of space and time. And light, the fastest thing in existence, became a tracer, a way to map the curves and folds of the cosmos. In regions of strong gravity, like near black holes, light can be bent into loops. It can orbit, trapped in circles. In even stronger gravity, it can fall in and never return. The light is not destroyed. It is simply pulled beyond the point where return is possible. This point is called the event horizon. Beyond it, not even light can escape. And since light is how we see, anything beyond that horizon becomes invisible. A hidden region from which no information can ever reach us. Black holes, then, are not just places where matter disappears. They are places where space folds inward and time slows down. And light is the quiet witness, the thread we follow until it vanishes. Even though we cannot see beyond the event horizon, we can see its outline. The way light bends around it, warps, and circles before slipping away. It paints a shadow, a dark shape made visible by the dance of light around it. And so light becomes our way of seeing the invisible, not by shining into the unknown, but by watching what cannot shine back. As you let this thought settle, feel how deep light travels, not just through distance, but through understanding. It reveals the contours of space. It outlines the mystery of gravity. It traces the silence at the edge of what can be known. You are drifting now through a universe curved by mass and motion. And light is your soft map, a silent stream that outlines the invisible. Let it guide you gently forward as we continue. Underscore. Part 10. Light speed and energy. We have said that nothing with mass can reach the speed of light. But why is this true? The answer lies in energy. To accelerate any object, you must add energy. At low speeds, a little energy goes a long way. Push a cart, and it rolls. Push harder, and it moves faster. But as your speed increases, something curious happens. The energy you add becomes less about speed and more about mass. In Einstein's theory, mass and energy are linked. As you go faster, your effective mass increases. And it takes more and more energy to continue accelerating. Not because your body gets heavier in the normal sense, but because the universe resists your motion. As you approach the speed of light, the energy required to go just a little faster rises dramatically. At 99% of the speed of light, your energy demand is immense. At 99.9%, it becomes astronomical. To reach the speed of light itself, you would need infinite energy, an amount the universe simply does not contain. And so, the speed of light becomes unreachable, not by rule or wall, but by cost. Photons, the particles of light, have no mass. And this is why they can travel at that ultimate speed. They are not accelerating. They are not being pushed. They are born at the speed of light, and they stay there. For everything else, light speed is not a goal. It is a boundary, a point we can approach, but never cross. And this boundary is what keeps causality intact. It keeps events in order. It ensures that effects follow causes, that the arrow of time flows smoothly forward. If anything could move faster than light, signals could be sent backward in time. The past could be changed. Reality would fracture. But it does not, because light is the limit. This limit preserves coherence. It keeps the universe from unraveling. It is not a barrier to progress. It is a quiet framework within which progress happens. So each time we accelerate a particle near the speed of light in giant machines on Earth, we are not trying to break the limit. We are studying how matter behaves as it leans against that boundary. We are listening to the silence just before the edge. And each time we observe light arriving from a distant star, we are not just seeing brightness. We are seeing endurance. A journey made at the one true speed allowed by nature. As you float in thought now, imagine the energy that fills the cosmos. Not wild or chaotic, but structured, channeled, moving always in the flow allowed by light. Let yourself rest in that truth, that the universe is not just moving, it is moving gracefully within a beautiful limit. And light is the quiet enforcer of that grace. Part 11. The Twin Paradox. Now imagine a thought experiment. Two twins, identical in every way, live on Earth. One stays behind. The other boards a spacecraft and travels far into space at near the speed of light. Years pass. The twin on Earth grows older, experiences the seasons, watches the stars. But the twin aboard the ship feels time differently. When the traveling twin returns, something remarkable has happened. They are younger than their sibling, not by trick, not by illusion, but by the reality of time itself. This is called the twin paradox. It is not a contradiction. It is a feature of how time bends when we move close to the speed of light. The twin on the spaceship experience time more slowly. Because the faster you move, the slower your clock ticks compared to someone at rest. This is time dilation again, but in human terms. The twin on Earth aged normally. The twin in motion aged less. And when they reunite, the difference is real. They are the same person in memory and heart. But their bodies and minds now carry different counts of time. This effect has been confirmed by experiment, not with people traveling through the stars, but with atomic clocks flown around the Earth. The clocks that moved showed less time than those that stayed still. The difference was tiny, but it was there. Real, measurable, proof of the bending of time. So if we could travel fast enough, far enough, we might leap forward in time. We could journey for what feels like a year and return to find a century passed on Earth. And yet, we cannot go backward. We can only move forward at different rates. The arrow of time still flows in one direction. The speed of light holds that arrow steady. And so light becomes the guardian of time's shape. It is the reason clocks tick, the reason events line up, the reason stories unfold in order. In this way, the speed of light is not just a measure of motion. It is the frame that defines memory, that connects cause to consequence, that gives time its texture. As you rest now, think of the twins. One carried by speed, the other by stillness. Each living a truth that is equally real. Each shaped by the quiet rhythm of time. Let this thought wrap around you. That time is flexible, but never broken. That the universe allows difference without chaos. And that in all things, light is the quiet bridge between now and next. Part 12. Information and Limits. Now imagine trying to send a message faster than light. A warning, a signal, a whisper to the past. The idea feels powerful, almost magical, but it is forbidden, not by rules, but by reality. Because information is bound to light speed. No message can move faster. No story can be told before its cause. And so, information becomes limited by this universal ceiling. This is not just about communication. It is about connection. Every interaction in the universe, from the pull of gravity to the exchange of particles, follows this speed. If you push something here, the effect there cannot arrive faster than light. There is always delay, always a gap, even if that gap is tiny. This limit is what keeps the universe stable. If information could travel instantly, events could happen out of order. Paradoxes would form. Logic would collapse. But light keeps the ledger straight. Every action leads to a reaction, but only after enough time has passed for light to carry the cause. Even quantum entanglement, where particles seem linked across great distances, does not send information faster than light. The connection is strange, but it does not break the rule. It dances with mystery, but respects the limit. This is why the speed of light is so fundamental. It is not just fast. It is final. It is the edge between what is possible and what is forbidden. And yet, this edge does not limit imagination. It focuses it. It helps us understand the rhythms of energy, the sequence of thought, the timeline of creation. It tells us that the universe unfolds in order, not all at once, not in chaos, but step by step, moment by moment. This gives us comfort. It means we are part of something consistent, something that builds upon itself, a slow, beautiful narrative that we are helping to write. As you breathe slowly, feel how light ties everything together, not just in space, but in understanding. It connects atoms to stars, seconds to years, questions to answers. And every signal you receive, every story you tell, every heartbeat you feel, all are bound by this limit. Not held back, but shaped. Not blocked, but guided. Not trapped, but composed. You are living inside this rhythm, this pace, this perfect unfolding. And the speed of light is the pulse that holds it all in place. Part 13, Light and Color. Now turn your attention to something familiar, something gentle, something you see every day without even thinking. Color. The blue of the sky, the green of trees, the warmth of sunlight. All of it, born from light. Color is not something that objects have. It is something that light brings. When white light shines, it carries every possible color within it, all blended together. But as it strikes a surface, some of those colors are absorbed, and some are reflected. The ones that bounce back reach your eyes, and your mind interprets them as hue and tone. Blue, red, yellow, violet, all different wavelengths, all different speeds of vibration in the same light wave. The faster the vibration, the shorter the wavelength. And the shorter the wavelength, the more energy it carries. This is why ultraviolet light can burn your skin, while red light feels warm and soft. But even though the colors differ in wavelength, they all travel at the same speed in a vacuum. That same steady, unshakable speed of light. When you see a rainbow, you are witnessing light spread out, separated by wavelength as it passes through droplets of water. The result is not just beauty. It is science laid bare. Light showing its hidden spectrum, revealing its layers like a song played note by note. Beyond the rainbow lies light we cannot see. Infrared, used by snakes to sense warmth. Ultraviolet, seen by bees and birds. X-rays, gamma rays, microwaves. All light. All part of the same family. All traveling at the same speed. Your eyes are tuned to a narrow band. A small slice of the total light spectrum. But within that slice is infinite detail. Infinite variety. The play of petals in sunlight. The shimmer of wings. The glow of twilight. And behind every color is speed. Light's constant journey across space. Its unwavering pace. Its patient arrival at your eyes. So when you look at something colorful, remember that what you are seeing is not just a surface. You are seeing the history of photons. Their travel. Their reflection. Their quiet gift of color. And when you close your eyes, the color fades. But the light remains. Still moving. Still humming. Still tracing its ancient path. You are part of that path. A receiver of its gentle messages. A witness to its endless motion. And in every color you see, there is a whisper of that ultimate speed. A soft reminder that the universe is lit not just by fire, but by precision. Part 14. Seeing the past in starlight. Tonight, above you, countless stars are shining. Some are small and cool. Others are vast and bright. Some are near. Others are so far that their light began its journey long before your ancestors walked the earth. Every star is a time capsule. The light it sends is a message from long ago. When it finally reaches you, that star may already have changed or even died. What you see is its memory, a record of what it once was. This is true for every point of light in the night sky. When you gaze upward, you are not just looking out across space. You are looking back across time. The closest star system, Alpha Centauri, is over 4 light years away. The light from it takes more than 4 years to reach you. That means you are seeing it as it was 4 years ago. For stars farther away, the delay is longer. For galaxies, it can be millions or billions of years. From GPS satellites circling Earth to distant telescopes measuring galaxy motion, the speed of light provides the standard. Without it, time would slip, break apart, drift from meaning. With it, the cosmos beats with one unified pace. Your phone tells time with accuracy because it speaks to satellites above you. Those satellites move fast and sit high, where gravity is weaker. Both motion and gravity shift the way time flows for them. The corrections that keep your clock precise depend on Einstein's equations, and those equations are rooted in the speed of light. Atomic clocks measure vibrations in atoms. Those vibrations are tied to electromagnetic energy. Light again. Its properties define seconds. They create time. So when you look at your watch, when a bell rings, when your heartbeat aligns with a song, you are syncing not just with a machine or a memory, but with the physics of light. The universe has no master clock hanging in the sky, no ticking pendulum across galaxies. But it does have light, and that light tells all things when to arrive, when to change, when to begin. This means time isn't separate from light. It is revealed by it, formed by it. And the limit of how fast light moves becomes the limit of how quickly anything can happen. So when you count seconds, when you whisper your way through a dream, when you feel a moment stretch or vanish, you are participating in the cosmic rhythm written by light. It's not just something we observe. It's something we live through. And even though we do not see the photons whirling around us, even though they move invisibly through space, they are still there, carrying time, holding the world together. Rest now in the comfort that time is not chaos, that it does not float free, that it moves with a silent beat, the beat of light, constant, soft, endless. You are not drifting alone. You are floating through that rhythm, safely held. Part 18. Light in the language of science. Everything we know about the universe, from the tiniest particle to the furthest galaxy, comes to us on waves of light. Telescopes do not touch the stars. They collect light. Spectrometers do not hold elements. They analyze how light bends, shifts, and glows. Microscopes do not brush against cells. They gather photons bouncing off tiny structures. Science is not about touching the distant. It is about listening to the light it sends. Every color in a flame reveals the atoms within it. Every flicker from a distant galaxy tells us how fast it moves, how far it is, and what it's made of. The way light stretches as it travels reveals how space itself is changing. We study the universe by watching how it shines. And all of this depends on knowing how fast that light travels. Without that speed, we could not calculate distance. We could not tell how long light has been in flight. We could not know when an event occurred or how long ago it ended. The formulas we use in physics, whether they describe gravity, motion, or magnetism, all fold the speed of light into their structure. It is not just a number. It is a cornerstone. Even the mass of a particle can be related to light through Einstein's equation. Energy equals mass times the speed of light squared. A relationship so precise, so elegant, that it transformed how we understand matter itself. This means that light isn't just a tool for vision. It's a tool for truth, a thread that runs through every scientific discovery, a universal witness. And yet, light is humble. It arrives quietly. It does not demand attention. It glows, reflects, bends, and passes on. You are surrounded by it, bathed in it, made from it. Your skin responds to it. Your mind maps the world by it. Your dreams are painted by it. And even in sleep, your brain stirs with memories touched by light. A smile seen in golden sunlight. A starlit sky over still water. A page glowing softly by a reading lamp. So as you listen now, as you drift through these thoughts, remember that everything you know about the universe has come to you on beams of light. Ancient, honest, patient. Let that knowledge rest in you like a quiet star. Let it remind you that even in stillness, something moves. Something bright. Something deeply constant. And that something is light. Part 19. The future of light. As we move deeper into understanding the universe, light remains our oldest companion, but it is also our guide to the future. In laboratories and observatories, we continue to discover new ways to use light. We bend it through fiber optic cables to carry ideas across oceans. We trap it in tiny chips to power artificial intelligence. We use lasers to heal the body, to sculpt metal, to cut through space itself. In medicine, light reveals what lies beneath the skin without a single incision. In communication, it encodes conversations that travel from one side of the planet to the other in fractions of a second. In astronomy, it reveals galaxies born billions of years ago, still glowing in the dark like distant beacons. And yet, light also opens doors to deeper questions. What lies beyond the visible spectrum? Can we one day use light to bend time itself? Might we use light to travel, not through space, but through understanding? We dream of solar sails, spacecraft powered not by engines, but by the pressure of light itself. We dream of using lasers to touch distant worlds. We dream of capturing the exact patterns of photons in a room and recreating them somewhere else. Not just images, but presence, memory, echo. And in all of this, light remains the key. Its speed still shapes what is possible. Its nature still defines the boundary between thought and reality. So while we move forward, we do not leave light behind. We move with it. We bend with it. We think in its language. We dream in its glow. Light may have been born in the first moments of the universe, but it has never stopped creating new moments since. And as you lie still now, you are surrounded by those possibilities. Each photon carries not just energy, but promise. Each flicker a seed of discovery. Close your eyes, and you may still feel the warmth of sunlight, the cool shimmer of a moonbeam, the gentle memory of a candle's glow. Light is not only around us, it is within us, and it moves forward, always. Part 20, A Universe Held by Light. Now, let the journey slow. Let the thoughts settle like dust in the quiet after starlight. You've traveled through ideas ancient and modern, simple and profound. Through gravity, time, distance, and wonder. And always, you followed one thread. The speed of light. It is not merely fast. It is foundational. It tells us where things are and when they happen. It binds the fabric of space-time into a form we can understand. It protects the order of cause and effect. It makes time flow. It makes space expand. It gives rise to color, to warmth, to vision, to life. We live in a universe not of chaos, but of rhythm. A rhythm guided by this one quiet speed. Not chosen, not invented, but discovered. As if the cosmos whispered a constant, and we learned how to listen. The speed of light is not loud. It does not shout. It hums. In the silence between stars, it travels unbroken. In the spaces between atoms, it dances unseen. In the long dark of night, it still carries stories from across the galaxies. And in every part of you, it flows. In every breath, every heartbeat, every blink, it leaves a trace. Even the galaxies we do see are affected by this stretching. Their light arrives stretched too, shifted toward the red, elongated. We call this redshift. It is not just a visual effect. It is a record of expansion, a soft signature in the starlight that tells us how space has changed. When we look at these redshifted galaxies, we are not seeing them as they are. We are seeing them as they were. And the light that left them left a much smaller universe. One that has grown and cooled and calmed as it spread outward. This redshift is like a memory, a whisper from the early cosmos, telling us not just what things were, but how they moved, how they changed, how the universe itself is not static, but alive with motion. And all of this is possible because of light's steady speed. It gives us a ruler to measure with, a clock to follow, a limit that does not restrict, but reveals. Without it, the stretching of space would be invisible, undetectable, unknowable. But with it, we can trace the shape of the universe. We can see its growth, its age, its story. And now, as you breathe gently, let that thought drift with you. That even in the stillness, the space around you is stretching. That the stars are moving away. That you are part of something grand and expanding. You are a witness to the quiet unfolding of a growing universe. And light is your guide through the darkness. Part 9. Light's Role in Gravity. Imagine now a beam of light passing close to a massive object, like a star or a black hole. Instead of continuing in a straight line, the beam bends ever so slightly, curving as it moves. It is not being blocked. It is not being absorbed. It is being pulled. Gravity, it turns out, affects light. This discovery changed how we understand both light and gravity. We once believed gravity pulled only on objects with mass. But light has no mass, and still, it bends. Why? Because gravity does not just pull. It reshapes the space around it. A massive object curves the space in which it sits. And light, following the straightest possible path through that curved space, ends up traveling along a bend. This means that light does not move through space as a guest. It moves as part of it. The path it follows is written by the shape of space itself, and that shape is written by gravity. This interaction between light and gravity was predicted by Einstein, and it was proven when scientists observed starlight bending around the sun during a solar eclipse. The stars appeared in slightly different positions because the light from them had been curved on its way to Earth. From that moment forward, we began to see gravity not as a force, but as a warping of space and time. And light, the fastest thing in existence, became a tracer, a way to map the curves and folds of the cosmos. In regions of strong gravity, like near black holes, light can be bent into loops. It can orbit, trapped in circles. In even stronger gravity, it can fall in and never return. The light is not destroyed. It is simply pulled beyond the point where return is possible. This point is called the event horizon. Beyond it, not even light can escape. And since light is how we see, anything beyond that horizon becomes invisible, a hidden region from which no information can ever reach us. Black holes, then, are not just places where matter disappears. They are places where space folds inward and time slows down. And light is the quiet witness, the thread we follow until it vanishes. Even though we cannot see beyond the event horizon, we can see its outline. The way light bends around it, warps, and circles before slipping away. It paints a shadow, a dark shape made visible by the dance of light around it. And so light becomes our way of seeing the invisible, not by shining into the unknown, but by watching what cannot shine back. As you let this thought settle, feel how deep light travels, not just through distance, but through understanding. It reveals the contours of space. It outlines the mystery of gravity. It traces the silence at the edge of what can be known. You are drifting now through a universe curved by mass and motion. And light is your soft map, a silent stream that outlines the invisible. Let it guide you gently forward as we continue. Underscore. Part 10. Light speed and energy. We have said that nothing with mass can reach the speed of light. But why is this true? The answer lies in energy. To accelerate any object, you must add energy. At low speeds, a little energy goes a long way. Push a cart, and it rolls. Push harder, and it moves faster. But as your speed increases, something curious happens. The energy you add becomes less about speed and more about mass. In Einstein's theory, mass and energy are linked. As you go faster, your effective mass increases. And it takes more and more energy to continue accelerating. Not because your body gets heavier in the normal sense, but because the universe resists your motion. As you approach the speed of light, the energy required to go just a little faster rises dramatically. At 99% of the speed of light, your energy demand is immense. At 99.9%, it becomes astronomical. To reach the speed of light itself, you would need infinite energy, an amount the universe simply does not contain. And so, the speed of light becomes unreachable, not by rule or wall, but by cost. Photons, the particles of light, have no mass. And this is why they can travel at that ultimate speed. They are not accelerating. They are not being pushed. They are born at the speed of light, and they stay there. For everything else, light speed is not a goal. It is a boundary, a point we can approach, but never cross. And this boundary is what keeps causality intact. It keeps events in order. It ensures that effects follow causes, that the arrow of time flows smoothly forward. If anything could move faster than light, signals could be sent backward in time. The past could be changed. Reality would fracture. But it does not, because light is the limit. This limit preserves coherence. It keeps the universe from unraveling. It is not a barrier to progress. It is a quiet framework within which progress happens. So each time we accelerate a particle near the speed of light in giant machines on Earth, we are not trying to break the limit. We are studying how matter behaves as it leans against that boundary. We are listening to the silence just before the edge. And each time we observe light arriving from a distant star, we are not just seeing brightness. We are seeing endurance. A journey made at the one true speed allowed by nature. As you float in thought now, imagine the energy that fills the cosmos. Not wild or chaotic, but structured, channeled, moving always in the flow allowed by light. Let yourself rest in that truth, that the universe is not just moving, it is moving gracefully within a beautiful limit. And light is the quiet enforcer of that grace. Part 11. The Twin Paradox. Now imagine a thought experiment. Two twins, identical in every way, live on Earth. One stays behind. The other boards a spacecraft and travels far into space at near the speed of light. Years pass. The twin on Earth grows older, experiences the seasons, watches the stars. But the twin aboard the ship feels time differently. When the traveling twin returns, something remarkable has happened. They are younger than their sibling, not by trick, not by illusion, but by the reality of time itself. This is called the twin paradox. It is not a contradiction. You are made from the same particles that release and absorb light. You are the echo of starlight formed in ancient fires. You are not just a watcher of light. You are part of its journey. And now, as sleep folds over you, let that truth rest inside. The universe moves, but not blindly. It moves on light. It spins, expands, and sings with a speed that shapes everything. So let the stars drift slowly behind your eyes. Let your breath slow to match the pulse of space. Let the light carry you, gently, safely, silently. And know that in every corner of reality, from the smallest thought to the farthest galaxy, one thing endures. The speed of light. Always the same. Always the guide. Always the quiet keeper of the cosmos. Good night.